Today we're going to talk about surface area and volume. To start, we're going to start with surface area. Surface area is the total of all surface area on a 3D object. And it's measured in centimeters squared, meters squared, feet squared. Etc. Let's take a look at our example. Our example is a prism. If you notice, there is 1, 2 triangles, 2 similar sides, and 1 bottom rectangle. So what we'd need to do to get the surface areas is we'd have to calculate 2 triangles plus 2 side rectangles plus the bottom rectangle. Now, just note, in this particular prism, we have 2 similar sides. That's why we have 2 side rectangles. On to cylinders. When you think of a cylinder looks similar to something like this. And a dashed line for the background portion of the circle. In essence, if you think about it, this portion here will represent the height of the cylinder, always. This portion here will represent the radius of the circle. So, if you think about it, there are going to be 2 end circles for the surface area plus the body of the barrel. This time we'll actually show the equation. So this is equal to twice times pi r squared for the area of the circles plus two pi r h. And now onto volume. When we discuss volume, we're actually talking about the space inside a 3D object. And it's measured in centimeters cubed, meters cubed, feet cubed, etc. Now, you heard me discuss the term prism earlier. Basically, what you need to realize is that a prism is a three-dimensional object, and what it has is, it actually has a single shape that is repeated on both ends of the single object. In this case, for this triangular prism right here, right, you notice that it has two triangles as its bases. We look at those as the base of the prism, the two repeated sides. So, if I wanted to find the volume of a prism, in order to get this, we would have to do the following. We take a look at the volume of a prism, and we're going to multiply the area of one of the sides, of one of the bases of the prism, i.e. in this case, our triangle. So we figure out the area of a triangle. And what we're going to do in order to get the volume is we're actually going to multiply it by its height. In essence, it's almost like if you take a look at a book. When you take a look at a book, there are an infinite number of pages that, when you slap them together, make up the thickness. You can think of this triangle as being repeated millions of times across the height of this triangle, or the distance. It doesn't matter. The distance between the two repeating sides. To calculate the volume of a triangular prism, we have to first identify the repeating sides, and we've already defined the repeating sides as this and this triangle and this triangle. So we're going to start by saying the volume is equal to the area of the triangle times the distance between the two repeated sides. And you could, in some books, you would say that that's the height, or you would call that, in this case, we'll just say that it's the distance. So, the volume, and now, is equal to the area of a triangle, which is base times height divided by 2 times, finally, d. Now, when we take a look at our cylinder, we have two repeated sections. We have two circles for repeated sections. So we're going to follow the same rules as before. We look for the two repeated sides, and we're going to figure out that it's going to be, for the volume, in this case, it's going to be the base, in this case, is going to be this and this, which means the area of the base is pi r squared. We're going to call this, on the cylinder, the height. And this will be our radius as before. Oh, let's go back to the original triangle, please. Let us call this the base of our triangle, and this the height of our triangle. And that means this part from here to here has to be the distance d. Sorry. Let's go back to our cylinder again. Now we must multiply by our height. When we take a look at this rectangular prism, the two repeated sides are this rectangle and this rectangle. And we'll look at this as the height of the rectangle. So let's label that accordingly. So this is going to be our length, this will be our width, and this will be the height of our rectangle. But literally, because this is our rectangular prism, it doesn't matter which sides are labeled the length, the width, and the height. So here we go. We're going to say the volume of this shape is going to be the length times the width, and then we're going to times that by its height. For each of the following examples, we're going to be calculating surface area and volume. So, first of all, we have our cylinder, and we notice our two repeated sides. We have our equation for our cylinder for the surface area. We will do the calculation. We'll write down the equation for that surface area right now. So basically, the surface area is equal to 2 pi r squared plus 2 pi RH. Make sure that this equation is on your cheat sheet for the test that will be coming up soon. Now, we're going to use this diagram to identify some things. So, this portion of our circle represents the diameter. So, the diameter is actually equal to 7. Our radius is equal to 3.5 centimeters. Now, we're going to call this portion here along the side the height. And in fact, it's 22 centimeters. Doing the appropriate substitutions, we should have something that looks like this. And you get, for your final answer, 560.8 centimeters squared for surface area. It's always important to remember that dealing with areas, you're always ending up with centimeters squared, meters squared, feet squared, etc. Now, since we've calculated the surface area, let's calculate the volume of our cylinder. The volume of our cylinder is determined by this equation that we determined earlier. V is equal to pi r squared h. We'll do our appropriate substitution. And calculating this, we get 846.7 centimeters cubed. You can pause here. Otherwise, I'm moving on to my new problem. The next problem is dealing with a triangular prism. This triangular prism has two repeated sides, just like before. So you remember this side is a triangle, and you notice that it's a right triangle. That's awesome. Saves us some time. The issue with this triangle is that I have these two sides, but not this side here. Because eventually we're going to have to calculate the area of this face of the rectangle. So we'll need to calculate this side here. To do so, I'm going to calculate it in red. So you remember Pythagorean Theorem? Pythagorean Theorem says that this side squared and this side squared must equal this side squared. So let's do that right away. So we're going to call this x. So we've got x squared, which is our longest side, is equal to 2.5 squared plus, oh my goodness, we have an issue. You notice how both sides of this prism, here and here, both are in meters. This side is in centimeters. In order to convert centimeters into meters, just divide by 100. So, just a quick thing, it's just a quick trick you should remember, make sure you have it on your cheat sheet. You divide that by 100 to get 0.45 meters. So we'll go and substitute into our calculation. So we got 0.45 squared. So 2.5 squared is 6.25, and 0.45 ends up being 2525. When you sum those two, you're going to get 6.4525 approximately. When you punch that in your calculator, so you have x squared as that. In order to get x by itself, we take the square root of 6.4525, square root it, and we get our final answer of x is equaling 2.54, and we'll just round it to approximately 2.5 meters. Since all of the units that are on the side of this triangular prism are 1 decimal place. Sometimes we just do things for simplicity. You could have left it as 2.54 and continued your calculation. Now take that 2.5 and we're going to put that on our shape. So that's 2.5 meters. So now we're going to calculate the surface area, then we will calculate the volume of this prism. So the surface area of the prism is the two triangles plus the bottom plus the side plus the top. So these represent my triangles. The two areas are going to be calculated like this: 2 bracket 2.5 times 0.45 divided by 2, plus this bottom side area, which has dimensions 2.5 and 1.2, Now, this side here has dimensions 0.45 meters for this edge, and this edge along here is also parallel to this, so that means this is 1.2. So the area of our side is going to be 1.2 times 0.45 plus the area of our final side. The area of our final side being 1.2 times 2.5 or 2.54. It's up to you. I think what I'll do is I'll use 2.54 to get a more exact value here. So 1.2 and when we calculate this, we can calculate this in 3 different parts. So we'll keep as much decimals as we can for this first part here, and we're going to get 1.125 plus, calculating this portion here will give us 3, plus this portion here, 1.2 times 0.45 will give us 0.54, plus the last portion here, 1.2 times 2.54, to give us 3.048, which will give us a total of 7.7 meters squared for the surface area. The volume calculation is going to be much easier. So, just like before, we need the volume of this prism. This triangular prism is basically going to be the area of this triangle times its height, which I will label here to be 1.2. So basically we need the area of the triangle. Let's do that first. The area of the triangle is going to be 2.5 times 0.45 divided by 2. Then we're going to times that by 1.2 to get a total volume of 0.675 meters cubed. Now we'll move on to calculating the volume and the surface area of this trapezoidal prism. The reason why it's called a trapezoidal prism is that I have a trapezoid here repeated on the back side of the prism. So this shape, if you recall, is called a trapezoid. Make sure you have a trapezoid equation on your cheat sheet for your test. Looking at this problem, based on my experience, calculating the volume of a trapezoid is much easier than calculating the surface area of a trapezoid. There's a lot more shapes in the surface area of a trapezoid than they are in the volume calculation. So we'll start with that. So the volume of this shape is going to be, we look for the repeated side. So the repeated side is going to be the trapezoid. I'm going to label this part A of my trapezoid, and this part B of my trapezoid, and this is going to be the H of my trapezoid. So now the volume is calculated as this: h times a plus b divided by 2, or a plus b times h divided by 2, and then we're going to multiply by the distance between the repeated sides. So that's d, which is 6.2 times 8.1 plus 12.4 divided by 2, and then we're going to times it by 2.9. Doing all the problems in one, doing all of this as one calculation gives you the following solution: 184.3 centimeters cubed. Now, we're going to perform a quick check to see if we have all of the side lengths for this trapezoid that we need for calculations. So, it looks like we have, we have this side, we have this side. Oh, okay. And we have this side, but we don't have this side. The nicest thing about this trapezoid is that if I draw, you notice how I have, this is perpendicular. Imagine if I drew a mirror image, drew a copy of that perpendicular to form a nice triangle here, here, and here. This will allow me to calculate this edge of this triangle, because I know that if this edge is parallel to this edge, that means this edge is 6.2 centimeters. So this edge is parallel to this, so this must be 6.2 centimeters. Doing some more careful study, we see that this edge is parallel to this edge. Now, if this edge is 12.4 and this edge is 8.1, that means that this edge of the triangle should be about 4.3 centimeters. Now we'll apply the Pythagoras rule on this portion of the triangle to find the hypotenuse. So we have x squared equals 6.2 squared plus 4.3 squared, which is equal to 56.93. So that means x squared is that. So now to get x by itself, we take the square root of 56.93 to get 7.5 centimeters. From here, we need to calculate the surface area of the entire prism. So the surface area of the prism is going to equal the two trapezoids plus the bottom, which is this whole bit here, plus the left side, plus the top, plus the slanted edge. So, let's clarify. This portion here is the left side, this is the bottom, this is the top, and this is the slanted edge. Now we will substitute directly into the equation. So we're going to get the following. Equals 2 times, now I'm just using a square bracket to emphasize that it's different. 6.2 bracket 8.1 plus 12.4 for the trapezoid divided by 2. Plus the area of the bottom, which is 12.4 times 2.9. Plus the left, plus the top, which is 6.2 times 2.9 again, plus 8.1 times 2.9, and then now for the slanted part, which is 2.9 times, I think this is, yes, I will label this 7.5 centimeters, plus 2.9 times 7.5. Upon calculation, we find out we have 226.28 centimeters squared for our surface area. Now please remember that your homework is going to be the assignment that I've provided on the website for your viewing, period. Good luck.